Hey everybody, so today we're going to be taking a look at a molecule called 2-pipridone. 2-pipridone has the molecular formula C5H9NO. Its CAS identification number is 675-20-7. Some of the chemiophysical properties of 2-pipridone. So it has 2 degrees of unsaturation, one coming from our ring system here, the other coming from our carbonyl pi bond. The functional groups involved in this molecule are a cyclic amide, also known as a lactam. And just so we can kind of get an idea of the naming system of lactams, so you start at your alpha carbon, which is the carbon next to your carbonyl carbon. And then we go through the Greek alphabet until we find the carbon that is bonded to the nitrogen. So we start here with alpha, beta, gamma, delta. So our delta carbon is bonded to our nitrogen, which gives rise to the name gamma lactam. So for this molecule specifically, we call it gamma valerolactam. Continuing on with some of the chemiophysical properties. So our molecular weight here is 99.13 grams per mole. Our melting point is roughly 2300 degrees Celsius. This comes from the physical state of 2-pipridone, which is an off-white or yellowish orange crystalline solid, meaning it's much harder to melt. And our boiling point is 256 degrees Celsius. And as mentioned earlier, it is a solid at room temperature. Just so we know, 2-pipridone is the monomer of nylon 5, and it's formed from the dehydrogenation of 5-amino 1-pentanol with catalytic amounts of rhodium and ruthenium complex. Just so we can understand this model we're about to look at, we'll go over some of the bond types involved in 2-pipridone. So we have 17 sigma bonds. This is a single bond. An example would be these 2 carbons here are sigma bonded to each other, as well as the 2 hydrogens that come off those carbons. So that accounts for 17 total sigma bonds. And then our 1 pi bond is coming from our carbonyl carbon up here. Hybridization. So we have 4 sp3 hybridized carbons and 1 sp2 coming from the carbonyl. Excuse me. We have our classifications of carbon over here. So we have no CH3, so no methyl groups, which is usually common for a ring system. We have our 4 CH2s, which we would call methylenes. We have 0 CHs or methynes, and then we have 1 quat carbon, which again is coming from our carbonyl. Now we'll take a look at our structure a little bit so we can try to understand a little bit more about gamma lactams. So I went ahead and built this structure in advance because it is a little complex to assemble. But as we see here, our ring system that was mentioned earlier, and this is our CO pi bond or carbonyl. And then we have our nitrogen attached. So our nitrogen actually does have 1 hydrogen bonded to it. By itself, we could call it a secondary amide because of the 2 bonds to carbon. The interesting thing to note about this molecule is that I know we said earlier that we only had 1 sp2 hybridized carbon in the molecule, which is true, coming from our carbonyl bonded carbon here. But we actually have 2 more coming from our heteroatoms in this molecule. So this oxygen is actually sp2 hybridized. And through resonance, you'll notice that this nitrogen becomes sp2 hybridized as well. So resonance would see the delocalization of the lone pair that's on nitrogen to give more of a double bond character between the nitrogen and the carbon here. That would mean that the pi electrons from the oxygen are pushed up onto our oxygen here, and that results in our 3 sp2 hybridized atoms here. All right, so thank you for listening to the talk about 2-pipridone, and I hope you have a great rest of your day.